this video, we're going to learn how to obtain the inverse of a 3 by 3 matrix. So for us to be able to obtain the inverse of a matrix, say A, noted by A raised to power negative 1, we're going to take 1 over the determinant of A times the adjoint of A. So it therefore means that for us to obtain this, we're going to need the determinant of A and the adjoint of A. So let us use examples so that we can understand how this works. So the first example is find the inverse of the matrix A, which is given by 3, negative 1, 2, 4, 1, negative 1, 5, 0, 1. So let us look at the solution. So the first thing to do is obtain the determinant. So the determinant of A is going to be obtained by observing the first row. So we're going to look at the elements one by one. So we're going to take the first element, that is 3, and multiply that by the determinant of the small matrix that is left when you cover its row and its column. That is this small matrix, that is 1, negative 1, 0, 1. Then you're going to subtract the second element, that is negative 1. When you cover the row and the column for negative 1, you get 4, negative 1. The other one that you get is 5, 1. Plus the third element, that is 2. Cover its row and its column, you're left with 4, 1, 5, 0. So let us work this out. So you want to have 3 into 1 times 1, which is 1, minus 0, minus minus, that is plus 1, into 4 times 1, that is 4, minus negative 5, that is plus 5, plus 2 into 4 times 0, which is 0, minus 5. So we have 3 into 1, plus 1 into 9, plus 2 into negative 5. That is just 3 plus 9 minus 10, which is just 2. So the determinant of that matrix is 2. So the next thing that we need to obtain is the adjoint of A. So for us to be able to obtain the adjoint of this particular matrix, we are going to get the cofactor of each and every element in this matrix. So we're going to start with cofactor of 3, because it is the first one. So 3 is in column 1, row 1. So we have negative 1 raised to power 1 plus 1 times the small matrix that is left when you cover its row and column, which is just 1, negative 1, 0, 1. So since this is 2, it is even, the negative will disappear. So we have 1 times 1, which is 1, minus 0. So we have 1 as the cofactor. Then you have the second element, which is negative 1. We're going to take negative 1. It is in row 1, column 2, so that is 1 plus 2. Then the small matrix that is left when you cover its row and column is 4, negative 1, 5, 1. So since this is odd, we have negative holding. So we have negative of 4 times 1 minus negative 5, which is just plus 5. So we have that to be negative 9. Then the cofactor of the next term, that is 2. So we have negative 1. It is in row 1, column 3. So that is 1 plus 3. The small matrix that is left is 4, 1, 5, 0. So since this is even, then this negative will disappear. So we have 4 times 0, which is 0, minus 5. So we have that to be negative 5. Then the cofactor of the next one, which is 4, will be negative 1. It is in row 2, column 1. So that is 2 plus 1. If you cover its row and its column, you're going to be left with negative 2, negative 1, 2, 0, 1. So since this is odd, the negative will hold. So you have negative 1 times 1, that is negative 1, minus 0. So that is positive 1. Then the cofactor of 1, that will be negative 1. So 1 is in row 2, column 2, that is 2 plus 2, and the small matrix that is left is 3, 2, 5, 1. 3, 2, 5, 1. So this is even, the negative will disappear, so we have 3 times 1 minus 2 times 5. So that is negative 7. Then the cofactor of the next element, that is negative 1, will be negative 1 raised to power. This is in row 2, column 3. So 2 plus 3. The small matrix that is left is 3, negative 1, 5, 0. 3, negative 1, 5, 0. So since this is odd, the negative will hold. So we have the negative of 3 times 0, which is 0, minus negative 5, that is plus 5. So that will be negative 5 because of this negative here. The next element that we have is 5. So the cofactor of 5 will be equal to negative 1. So 5 is in row 3, column 1. So that is 3 plus 1. Cover its row and its column. We left with negative 1, 2, and 1, negative 1. So that will be, this is even, the negative will disappear. So you have negative 1 times negative 1, which is 1, minus 2. So that is negative 1. Then the cofactor of 0, that will be negative 1. So 0 is in row 3, column 2. So that is 3 plus 2. The small matrix that is left is 3, 2, 4, 1. 3, 2, 4, negative 1. So since this is odd, the negative will hold. So we have 3 times negative 1, that is negative 3, minus 8, that will be positive 11. Then finally we have the cofactor of 1, that is negative 1. It is in row 3, column 3, so that is 3 plus 3. And the small matrix that is left is 3, negative 1, 5. 3, negative 1, 4, 1. 4, 1. So since this is even, the negative will disappear. So we are left with 3 times 1, which is 3, minus negative 4, that is plus 4. So we have that to be 7. So now we have the cofactor matrix. So our cofactor matrix is given by 1, negative 9, negative 5, 1, negative 7, negative 5, and negative 1, 11, 7. So we can obtain the adjoint of A just by obtaining the transpose of this cofactor matrix. So the transpose is just formed by taking the first row to be the first column, the second row to be the second column, and the third row to be the third column. So we are going to have that as 1, negative 9, negative 5, 1, negative 7, negative 5, and we are going to have the last one as negative 1, 11, 7. So that is the cofactor, not the cofactor but the adjoint of the matrix A. And now that we have the determinant of A, so the determinant of A is 2, and the adjoint of A is 1, 1, negative 1, negative 9, negative 7, 11, negative 5, negative 5, 7. So we can now obtain the inverse of A. Yes, 1 over the determinant of A, and the determinant of A is 2. Then we're going to multiply that by the adjoint. Negative 9, negative 7, 11, negative 5, negative 5, 7. So if you like, you can leave it at that, or you can open it up. So if you open it up, it will be 1 over 2, 1 over 2, negative 1 over 2, negative 9 over 2, negative 7 over 2, 11 over 2, negative 5 over 2, negative 5 over 2, 7 over 2 as the inverse of the matrix A. Let us go to the second example. So example 2, find the inverse of B given by 3, negative 3, 4, 2, negative 3, 4, 0, negative 1, 1. So as we said before, obtaining the inverse of the matrix B will involve 1 over the determinant of B, then you multiply that by the adjoint of B. So the first thing to do is just to obtain the determinant of B. So like I said before, we're just going to take the first row. We're going to look at the elements in the first row. So we're going to take 3, then you multiply that by the determinant of the small matrix that is left when you cover the row and the column of 3. So that is -3, 4, and we have -1, 1, minus the second element, which is -3. When you cover its row and its column, you're left with 2, 4, 0, 1. 2, 4, 0, 1. Plus the third element, which is 4. You cover its row and column, you're left with 2, -3, 0, -1. So let us work this out. So we have 3 into -3 times 1, that is -3, minus -4, that is +4. Minus minus, that is +3 into 2 by 1, which is 2, minus 4 by 0, which is 0, plus 4 into 2 by -1, which is -2, minus 0. So we have 3 into 1 plus 3 into 2 plus 4 into -2. So that is 3 plus 6 minus 8. So that is like 9 minus 8, which is just 1. So that is the determinant of B. So the next thing we need is the adjoint of B. So for us to obtain the adjoint of B, we are going to look at the cofactors of all the elements in that particular matrix. So we are going to start with the cofactor of the first element. The first element is 3. So the cofactor of 3 is going to be equal to, take -1, it is in row 1, column 1, and then when you cover its row and its column, you're left with -3, 4, -1, 1. So let us work that out. So because the power is even, the -1 will disappear. So I'm left with that is -3 times 1, which is just -3, minus 4 times -1, which is -4, so that is +4. So that is 1. Then we're going to look for the cofactor of the second element, which is -3. So you have -1, it is in row 1, column 2, and the small matrix that is left when you cover its row and its column is 2, 4, 0, 1. So since this is 3, that is odd, the negative will hold. So we have the negative of 2 times 1, 2 minus 0. So that will be -2. Then you also look for the cofactor of the element 4, this one here. So that is -1. It is in row 1, column 3. And then the small matrix that is left is 2, -3, 0, -1. So since the power is even, the negative will disappear. So you're left with 2 times -1, which is -2, minus 0, so that is still -2. Then the cofactor of the second, the element, or the fourth element, which is 2, -1 raised power, it is in row 2, column 1, so that is 2 plus 1. The small matrix that is left when you cover its row and its column is -3, 4, -1, 1. So since the power is odd, we're going to have the negative. So you have -3 times 1, which is -3, minus -4, that is +4. So we have -1. Then let us look for the cofactor of -3. So -1 raised power. So -3 is in row 2, column 2. That is 2 plus 2. and the small matrix that is left when you cover its row and column is 3, 4, 0, 1. 3, 4, 0, 1. So since the power is even, we have positive, so 3 times 1 minus 0, so that is 3. Then the cofactor of 4, you have negative 1, so it is in row 2, column 3. When you cover its row and column, you're left with 3, negative 3, 0, negative 1. So since this is odd, you're going to have negative 3 times negative 1, that is negative 3, minus 0. So that is positive 3. Then the cofactor of 0, we're going to have negative 1. So 0 is in row 3, column 1. So that is 3 plus 1. Cover its row and its column, you're left with negative 3, 4, negative 3, 4. So since this is even, the negative will disappear. So you're left with negative 3 times 4, which is negative 12, minus negative 12, that is plus 12. So that is 0. Then let us look at the cofactor of negative 1. So negative 1 is in row 3, column 2. 3, column 2. So when you cover its row and its column, you're left with 3, 4, 2, 4. 3, 4, 2, 4. So since the power here is odd, the negative will hold. So you have 3 times 4, that is 12, minus 8. So that is 4 times that negative, that is negative 4. Finally, we have the cofactor of 1. So negative 1. So 1 is in row 3, column 3. So that is 3 plus 3. Cover its row and its column, you're left with 3, negative 3, and 2, negative 3. So since this is even, the negative disappears. So you have 3 times negative 3, that is minus 9, minus negative 6. So that is negative 3 times 2, that is negative 6. So plus 6. So that will give you negative 3. Now from this, we can form the cofactor matrix. So you have the cofactor matrix, which is just 1, negative 2, negative 2, 1, negative 2, negative 2, negative 1, 3, 3, 0, negative 4, negative 3. So that is our cofactor matrix. So we can obtain the adjoint matrix from this by just taking the transpose of this cofactor matrix. So we'll do that by just using the first row to form the first column, that is 1, negative 2, negative 2, and the second row, negative 1, 3, 3, then you have 0, negative 4, negative 3. So that will be the adjoint of that matrix. So we can use this under the determinant to obtain the inverse of B, which is just 1 over the determinant, which we found to be 1, times this adjoint, which is 1, negative 1, 0, negative 2, 3, negative 4, negative 2, 3, negative 3. So that is 1 times this, which is just 1, negative 1, 0, negative 2, 3, negative 4, negative 2, 3, negative 3, as the inverse of B. So now you can take this for your practice or as an assignment or as an exercise. So find the inverse and the inverse of, so let the first one be C is given by 1, 2, 1, 3, 2, 3, 1, 1, 2, and the second one, D, is given by 1, 1, 1, 1, 2, 3, 1, 3, 4. So attempt these two and leave your answer in the comment section. Thank you for watching. Kindly subscribe to my channel.